Hi, everybody, and welcome back to Chee-Tash. My name is Chris. Today, we're going to be talking about Eloquent JavaScript by Merjan Haverbeek, and we are talking about Chapter 6, The Secret Life of Objects. We're going to do things a little differently today, if you guys can see that on the PowerPoint side over here. We only got one slide. I'm only really going to focus on one thing today. I might as well show it to you. You see it right there on the title slide. And that is encapsulation. I didn't really put it there, but it's on the title slide, encapsulation. What is encapsulation, how you can do it in JavaScript, because this is really, really big in Java world. Because when I think about encapsulation, I think about classes. And in Java, we're constantly writing classes. In all my experience with JavaScript, I've barely written classes before. I mean, I've seen some tutorials that do it, but I never think to use it because from what some JavaScript devs have told me, JavaScript is more so like for functional programming and not OOP, object-oriented programming. And that's not to say that there aren't objects in JavaScript. Remember, we've talked about it before. Everything in JavaScript is an object. Arrays are objects. Functions are objects. You can even say right there, object, function. Objects are objects, obviously. So I have not really seen this, even on like this little JavaScript node project that we're doing right now. We don't really use classes in there. Not really. So it's something that I think Merjan put in here just for like completion's sake. I don't know if you're going to see it too much out there in the real world, but encapsulation doesn't necessarily have to mean classes. And in JavaScript, it can mean, essentially, here's what it means. And you can see the quote there. This is from the text, from the first section of Chapter 6, where it's essentially encapsulation is separating the interface from the implementation. So you hide all the details, kind of like what we talked about with abstraction, where the details are hidden away in a function, and then you just call that function, but the people don't see how the function works under the hood. So what are interfaces? Well, interfaces, from what I read, interfaces are not really in JavaScript. There are ways to get around that problem by doing, what's it called, like ducking, duck implementation. Here, we'll do a quick search. It's something called like duck typing. Duct typing, I think, is what it was. Because I think I was looking at like this first the Stack Overflow question right here. And I swear he puts it in here, or she puts it in here. Duck typing, yep. Instead, JavaScript uses what's called duck typing. If it walks like a duck, quacks like a duck. As far as JS cares, it's a duck. So how you can create, what was the question? Interface type. So you can essentially do like a check here, some object.quack equals function. This thing can quack, and then you can go ahead and quack. So you check for the quack, and then you can do the quack. There's also, I'll show you a way from a tutorial I was looking at how to implement like a quote unquote interface. It's just really different because JavaScript doesn't really, you can do imports. In Java, we just have everything separated out in classes. But in JavaScript, you can have things separated out and then import it into the other class. I mean, it's kind of the same, but it's kind of different anyway. I'm going off on tangents here. Back to the lecture at hand. So that's what encapsulation is from Mergen's view. From the MDN documentation, it's the packaging of data and functions into one component where you only need to know the interface in order to like call those components of the component, call that data and functions from that component. So what's an interface? An interface is a set of functions or bindings. This is where in Java we would use the implements keyword. So we would say something like a class. This isn't going to work here, but public class, my class implements my interface, and then we would have brackets, and then we would have to, because this is just a rule in Java, you have to implement all the methods from an interface. It's like signing a contract. So you can then, my interface could maybe contain like two methods, do this and do that, right? And then in my class, you can then implement those methods, do this and do that, any way you want to. You could do whatever you want to them. But then in another class, you can call implements my interface, and you can do this and do that, but you can do entirely different things in those methods. So you're separating it out by interfaces. And that's where the abstraction is. The implementation is hidden in the classes, but as long as you know what to call, as long as you know to call do this or do that, then you'll be good. You can use those when objects are created from this class. I have to find, God, I was reading something how object creation, oh gosh, I wish I could remember it. I wish I could find this article. It was like classes, JavaScript does object creation from classes, and then Java does it from objects, something like that. That totally doesn't make sense. I'll have to find it again. I can post it in the comments section for you guys if I find it. It was very profound. So encapsulation, it doesn't have to be at the class level. This create counter here, which I took from one of these tutorials I was looking at. Yeah, one of these tutorials I was looking at. This create counter variable, we're binding it to a function. And look what it does here. It's got let count equal to 0. And then it's returning an object where the object has two attributes. It has a click and a get count attribute. Those return, or excuse me, those attributes, the click attribute has a value, has a function value that returns count plus 1. Get count has a function that returns count, basically essentially what the count is, the string format of the count. So this variable, you could say maybe is encapsulated in here. The data, the functions are all inside this create counter component, inside this function that we're binding to create counter. Right, so now we assign the function create counter to counter. Okay. And now, what does create counter return again? The function create counter returns a function. So now this counter binding has access to the properties, which we're going to access via dot notation here, right? And this is an object. Or excuse me, did I say it returns a function? It returns a object. Sorry. So that's why you're able to call this dot notation here, right? You're calling a property of the object, the click. What is click? Click is assigned to a function, so we're going to call it with the parentheses, right? Because if you didn't do it with the parentheses, I'm assuming Oh, well, that's very interesting. You don't need the parentheses here? Because I would have figured we would have gotten like a object function call, which is what we're getting here. I guess you don't need it. So when you call counter.click, it's going to take count starts at 0. You add 1 to it, you're going to get 1. Now, here's the interesting thing, and this is what I was kind of confused by, still am a little bit confused by, is you have counter.click, right? You call it again, and you get 2 instead of 1 again. Because this count variable is within the scope of create counter. You're calling it again, right? So this has already been set in the lexical scope of this function, right? So when you call it again, you're calling count, which is 1 now, plus 1. Now you call it a third time, you're calling .click. It's going to be count, which is 2 now, plus 1, which is 3. Right? This doesn't get reset to 0 after every time, because this is what is getting returned. If you guys see what I'm saying, it doesn't come up here and get reset to 0. Whenever you call counter.click, it comes here and then it comes to the click, essentially, is what I'm trying to say. So that could be encapsulation there. Now, I am really disappointed that I had some other code here, and I hope it shows. Nice, there we go. So now here's encapsulation from a class standpoint, where we actually do define an interface. We'll talk about that symbol in a second, but we have this class sample, class called sample. The constructor, it has one field variable, one attribute, which is a count. This .count. This in the context is meaning at the class level. We are going to have to talk about this at another time. Basically, this has to do with like either the object or the function that's calling the variable, and if it's not within that, then it's set to the global context. But in this instance, it's to the context of this class. So whatever we pass in to create an object of sample, like 2, for instance, that's what's this .count is going to be assigned to 2. This class has a click method. It's got a get count method. And then it has this get and then my interface implementation right here using brackets. Which I thought this was like a really interesting way to write this. I was wondering why it does this, why this is needed, but I think it has to do with the fact that you're assigning this my interface binding to the symbol my interface, the string my interface. Mergen introduces symbols a little bit later in chapter 6, and Mergen states that symbols, this is reading from the book, symbols are values created with the symbol function. Unlike strings, newly created symbols are unique. You cannot create the same symbol twice. So this symbol, my interface, is unique. You cannot create it twice. So essentially what you're kind of doing, it's kind of like an interface in Java in a way, where you have these methods. You can't change them, but you can implement them. So we're going to take the same my interface and implement it in 2 classes here, because you see, and this is kind of jumbled up here in REPL, but I have this one class sample, then I have another class sample 2. we're going to implement the same my interface, but we're going to do different things to it. As you can see, sample 2, and we do some different things in this class. Add 5 instead of 2 up top there. In the my interface, we're going to say add 10 to it instead of adding 2 to it. So remember, bracket notation means that it gets everything in the brackets gets evaluated. So this gets evaluated to my interface, right? String my interface. And now we have this function here that's going to take in an object, and it could be any object, right? Any object, as long as it's implementing this my interface. So when you assign interface to object object property of object my interface, what are you really saying there? Well, where does this my interface come from? Comes from up top there. This is essentially, like it says there, a constant. This is unique. So now the object at my interface, object property my interface is going to get evaluated, which is here, and it's going to do either this.count10 or this.count2. So we create a new object via the new keyword, new sample of 2. Remember, it's taking in a variable, just one count variable here. So we have sample, and then we have sample 2. All right, so now when we call sample interface, the first one, we're going to call this. It knows to call the highlighted my interface implementation here, and that's why you get 2 there. Or wait, no. That's why you get 4 there. There we go. When you call that. So let me comment that out, and now you can see these other 2. So testing interface sample 2 and testing interface sample. All right, so look again what this function does. Binds object my interface to interface. It's going to check if interface is undefined. If it's not undefined, we're going to return interface. So we're going to return this, this expression here. So what happens when I uncomment these 2? Something got evaluated. We got 12 and 4. So for sample, this one we got 12. And for this one, we got 4. Does that make sense? Well, let's take a look. Sample 2, right? We're calling this. We assign 2, right? We're initializing it with 2. 2 plus 10 is 12. Up top here, for the object we created from sample, we initialize with 2. 2 plus 2 is 4, right? And when we're calling the functions, it's all encapsulated, right? So you can, this is really nice because you don't have to specify the object here. You don't have to say, hey, I only want to pass in sample 2 or sample objects. No, just object, and then whatever object has the my interface implementation, that's what's going to get returned here. That's what's going to get called. That's going to do it, guys. Let me know if you have any questions about encapsulation. Hopefully I explained it okay. Let me know if you have any questions in the comments below. I'm going to try to find that article. God, it's going to bug me because it was so profound what I read. Thank you guys so much for listening. We'll do another topic from chapter 6, maybe talk about some methods and classes, specifically about classes. I know I kind of just ran through it a little quick. class, keyword, constructor, getters, setters. But let me know what you think. Please like and subscribe. Thank you guys so much for listening. My name is Chris. This has been Chee-Tash. Take care.